One model is no longer enough for agentic workflows. Today, AI agents need multiple models working together to get stuff done, with the right balance of accuracy, efficiency, cost, and control across all tasks. A system of models. Now, a system of models works best when each task reaches the right model. And most teams kind of already do this, right? They assign models to specialized sub-agents when they're building the models. When you're building a workflow out using LLMs, you're going to have the models that you prefer for different tasks. The planner is going to get like a frontier class model. The search agent might get a specialized open model, and maybe some, very sensitive data accessing model is going to run on-prem on a local device. This is a great idea. It helps. But in real workflows, kind of demands are going to shift turn by turn, right? A search agent might hit something a little bit ambiguous. A normal step that's not supposed to be difficult might suddenly need deep reasoning. Static assignments can't really help us with that. That's the difference between assigning a model and then orchestrating models across a workflow. NeMo Switchyard helps agents do exactly that. It routes dynamically. It's going to read the live context, the state of the agent, tool results, progress, difficulty to pick the right model at every step. Under the hood, Switchyard takes a few components. It's going to take a model pool, some signals, a decision policy, more on that in a second, an execution layer, and a feedback loop. Let's take that down step by step. So first of all, the pool, right? Routing only works if we have a pool of models that are genuinely different from each other. Frontier models for planning and open-ended reasoning, specialized open models for targeted specific work, execution style tasks, and small local models where control is of most importance. Each target carries a capability profile, like what it's good at, what it costs, how fast it responds, all of that stuff. And the profile is what the router is actually going to choose between. Secondly, signals. What can the router actually see when it decides, right? We have the request. So this is like, what kind of task is this? How difficult could it be? The conversation itself, this is things like looking back through the turn history, looking at tool results, looking at how far we're moving down the to-do list. And finally, of course, the models themselves can emit signals, things like confidence that we read directly from a forward pass. Better signals mean better decisions. Some signals are costly to extract. And that trade-off is kind of, the big deal. Next, we're going to talk a little bit about execution. This is the idea that we need some kind of layer to actually execute the request. So the router is going to make a decision, and then that decision needs to be sent somewhere to do work. This is something like, in the case of NVIDIA NeMo Switchyard, right, we're going to pass that to an LLM gateway or the agent harness, which is then going to send that request to the correct model via its typical API. Lastly, feedback. We need kind of telemetry to understand, are we getting better? Are we doing well? Are we actually saving costs? We can benchmark routers and understand that they should perform better, but without feedback, we're kind of in the dark when we're actually running these in production. Lastly, the thing I didn't talk about is the routing or decision policies. And this is kind of like the whole thing. These are the algorithms, the beating heart of something like NeMo Switchyard, which tell the router how to choose between models in a pool based on signals. So let's go through a few examples of them. First of all, we have the LLM classifier. The LLM classifier is going to put a tiny classifier in front of the pool of models. It's going to read incoming requests and issue a verdict. Does this need to go to the strong tier? Does this need to go to a specialized model? Those kinds of decisions. The idea here is that we can set how, aggressive we want that policy to be with our classifier, so we can kind of have a knob to tune when it comes to how much we want to prefer one model versus the other. In the case of like a strong weak classifier, we might want the model to lean towards strong for use cases where being wrong is costly, or lean towards weak for use cases where being wrong is not very costly and efficiency is extremely important. Next, we have Cascade routing, and it gets its signals kind of for free. In an agent loop, evidence is already flowing. Tool calls, succeeding or failing, retries, progress towards the goal. The Cascade reads that evidence and holds most turns on the efficient tier. It only escalates when the signals say the model is struggling. So this is like we're slamming tool calls over and over again. We're banging our head against the wall. Hey, go up to the next tier, my guy. This is something like Cascade routing. Lastly, we have something like the prefill router. This goes one level deeper and it considers a lot of signals, including signals from the model itself. Before the model can generate anything, it has to prefill. So we have to load things up and do a full forward pass over the prompt. That pass is dense with signal, token level confidence, and internal states. We read it, and with a bunch of other factors that we consider, like how fast the models are, again, all of these signals we have, we can determine with pretty decent confidence whether or not to go to the model that was selected. Now, this is a trainable router, which means that we have to do some work to make it work great. But that work makes it work really great. So finally, let's just recap, right? We had pools, signals, we have the decision policy, we have execution, we have feedback. The most capable AI systems aren't one model anymore, they're many. And routing is how many models become one system with something like NeMo Switchyard. Thanks so much for watching. We'll see you in the next one.